Good afternoon, students. Last time we solved exercise 2.4 based on area of similar triangles. Today we are going to study regarding Pythagoras Theorem. Before we study Pythagoras Theorem, there is a history regarding this theorem, how this theorem was invented. Its history is way back in the 4th century, that is Babylonian civilization. So in 4th century Babylonian civilization, by the time the people were knowing regarding the numbers. You know what is the number system? Numbers are there, 1, 2, 3, 4. This was the numbers which we knew. So they took certain numbers. For example, 3, 4 and 5. They took the square of these numbers. That is, they squared 3, they squared 4 and they squared 5. Square of 3 is 9, square of 4 is 16 and square of 5 is 25. And to their surprise, what they found that when they added the 3 square and 4 square, they found the result was equal to 25, which they gave name as triplet. Similarly, one more example I can give you, 6, 8 and 10. 6 square, 8 square and 10 square. 6 square is 36, 8 square is 64 and 10 square is 100. 6 square and 8 square was added, it became equal to 100. So these were called as triplet. Triplet means 3 numbers. Keeping this in the mind, in 6th century, great mathematician named Pythagoras, he derived that these triplets can become true only if right angle triangle is taken, and he was able to give us the theorem based on right angle triangle, which is called Pythagoras Theorem. This I will later on explain what is this. After the 6th century, even our Indians were not at the back. They also found out regarding the Pythagoras Theorem. And the mathematics, that was in 7th century, and the mathematician was Bodhiana. And he wrote a book which is called Sulba Sutras. In that, regarding this Pythagorean triplet is there. What he told, what was the Bodhiana's theorem, it is quite different than the theorem given by Pythagoras. The statement is little different. What he told us, he took it rectangle. That means the area produced by the diagonal of a rectangle. The area produced by the diagonal of the rectangle is equal to the areas produced by their sides. That is what the Bodhiana gave the theorem. The area, that is, he took a rectangle and he joined one diagonal. So what he did, he took and created one more rectangle over here, created one more rectangle over here, and along with this, here also he created one more rectangle. So he got 1, 2 and 3, and he compared. The second area is equal to the sum of first area and third area. That is the square of the side of the rectangle and the square of the side of this rectangle and square of the diagonal. So 2 square is 1 square plus 3 square they were able to do. That means what? If this is 2 centimeter and if this is 2 centimeter, they took that and they found out that 2 square is equal to 1 square plus 3 square. That is the square of the first square, the square of the side. That is, this is the first side. This is first side square. So first side square plus third side square is equal to second side square. So first side square plus third side square is equal to second square side. That is what Bodhiana proved. Today we are going to learn regarding Pythagoras theorem, but in this one thing I want to tell you. The Pythagoras theorem, his proof is different, but for you in 10th standard, you have to learn the proof which was given by Bhaskar. That is Bhaskar's proof with regarding similarity. That is a proof we have to study. Pythagoras gave proof, but that proof is quite different than the proof what we are going to study in Pythagoras theorem. But the statement is given by Pythagoras theorem, but the proof we are going to take the Bhaskar's proof, which is given by Bhaskar, and it is depending upon the similarity. In any right angle triangle, very important statement. So what does the statement says? In any right angle triangle, prove that the square of the hypotenuse is equal to sum of the square of the other two sides. So very important. In any right angle triangle, the square of hypotenuse is equal to sum of the, this word is very important, sum means when we will sum 2 and 3, what is sum of 2 and 3 means? We will add 2 plus 3 is equal to 5, and here sum is very important, sum of the square of the other two sides. So this is what the statement of the Pythagoras theorem. So once again I will say, in any right angle triangle, the square of hypotenuse is equal to sum of the square of the other two sides. Okay, first I want to know hypotenuse, which side is called as hypotenuse in a right angle triangle. You may not be knowing. I'll teach you which is a hypotenuse, because if you don't know to recognize hypotenuse, you won't be able to solve the sums based on the Pythagoras theorem. So suppose if I take A, B, C and angle B is 90 degree, then the side which is opposite to 90 degree is AC. So the side which is opposite to 90 degree is called as hypotenuse. So always remember, in a right angle triangle, which side is called hypotenuse? The side, the opposite to right angle is called hypotenuse. And these two sides are called the legs of the right angle triangle. That means hypotenuse square is equal to sum of the square of the legs of the right angle triangle. That is what the Pythagoras told us. So now the statement is along with you. Again, once again I read. In any right angle triangle, you have to prove that the square of hypotenuse is equal to sum of the square of the other two sides. So you know that whenever theorem is there, you need a diagram. So we have to draw a diagram. What is the name of the triangle given over here? It is not here. So we will take, let us take ABC as a triangle. What type of triangle? Right angled, very important. So I am going to draw a right angled triangle. Okay. And I am going to take angle B is 90 degree. So ABC I have drawn a right angled triangle. Why it is called a right angle triangle? Because B I have mentioned, and this mark is only used for right angle. When I was teaching you the triangles, that time also I told you, this is only used for right angle, this mark. So angle B is 90 degree. So given, very important. So what is given? What is given? ABC is a right angle triangle. Triangle ABC is a right angled triangle. Okay. And which angle is 90 degree of marked? That also you have to show that angle P is equal to 90 degree. So this is very important given. So what does the given says? Name of the triangle ABC is a right angle triangle. What type of triangle? Right angle triangle. Which angle is 90 degree? B is 90 degree. Okay. After given, we have to go to prove. What you have to prove? Square of hypotenuse. Okay children, I told you which is the hypotenuse. Angle B is 90 degrees. So which is the hypotenuse? AC is the hypotenuse. The square of the hypotenuse. So AC square is equal to. It is equal to what? Sum of the square of the other two sides. Which are the other two sides? AB and BC. Its square means AB square and BC square. Its sum means AB square plus BC square. So AB square plus BC square. This is what we have to prove. To prove this, you can't prove with this diagram. You need to draw or construct. What is the construction you are going to do? I told you from B, you are going to draw a perpendicular line. Means you are going to draw a height. Perpendicular line is what? It makes 90 degree with the base. So you are going to write down construction. Very important. What is the construction over here? Construction is, what is the perpendicular line? Name of the perpendicular line? BD. It is perpendicular to which line? AC. So draw BD perpendicular to AC. This is a symbol of perpendicular. So came to know what you are going to draw? BD you are going to draw perpendicular to AC. Okay. Now we will start with the proof. Proof we are going to take Bhaskar's proof regarding or based on similarity. Now children, can you see that? Here three triangles I got by drawing BD perpendicular to AC. ADB is one triangle, BDC is another triangle, and the original triangle ABC is the bigger triangle. So we are going to compare the triangles. And we are going to prove they are similar, and we are going to take the sides proportion. So which triangle to which triangle? The smaller triangle ADB, I am going to compare it with the bigger triangle ABC. Then second time, again the smaller triangle BDC, and I will compare with the triangle ABC. So two times the similarity triangles I will take. First ADB with ABC and second BDC with ACB. Now how I have to write down the triangle name? Very important. Here in ADB triangle, which angle is 90 degree? D. So D has come in the center. So for ABC also B should come in the center, because D and B are the corresponding vertices. A you can see is a common vertices. So A, D, B, then I will write down A, B, C. A corresponds to A, D corresponds to B, and B corresponds to C. So what shall I start? In triangle ADB and triangle ABC. So we have taken triangle ADB and triangle ABC. We are going to compare it. We are going to make similar. We know the similarity criteria. A, SSS, SAS. Here we are going to take AA criteria. How? Now we know that angle ADB is equal to angle ABC is equal to 90 degree. What is the reason over here? The reason is given and the reason is construction. Through construction and through given, we can prove that it is, what to call it as? It is 90 degree. So again, once again I am telling you, angle ADB and angle ABC. It is 90 degree because it is given and construction. Now, second angle. Just now I told you, A and A is corresponding to each other. So common angle is there. So which is a common angle? Angle BAD is equal to angle BAC. So it is common angle. I got it. So no need to go to the third angle. So I can prove that triangle ADB, similar symbol to triangle ABC. So now I have to take the side proportional. If you don't know the side proportional, easy method I will show you. In the side over here, you show the corresponding vertices. A corresponds to A. Then D corresponds to B and B corresponds to C. Now you can take the sides. If you take AD, here you have to take AB. If you take DB, here you have to take BC. If you take AB, you have to take AC. First I want AB square. If I multiply, cross multiplication if I do, that means AB is up, then here AB should come down for cross multiplying when I take the ratio. That means if I take AB in the triangle ADB, then which is the another side, the corresponding side, I have to take AC. So I took AC over here. Now, cross multiplying AB square I should get. So AB, if I take here in this bigger triangle here, what should come over here? AD should come. So if I cross multiply, what shall I get over here? I will get AB into AB is equal to AC into AD. What is AB into AB? AB into AB is nothing but it is AB square is equal to AD into AC. So this is for first triangle we have taken. So AD into AC we got it. So which triangle? ADB and triangle ADC. Now again one more triangle we have to take into consideration. Which consideration? Just I told you when I was explaining this. The smaller triangle BDC and the triangle, bigger triangle ABC. In that also we have to prove the same. We have to show that triangle BDC is similar to triangle ABC. So there also we are going to take the same thing. So in triangle BDC, first smaller triangle, and triangle ABC. Here again we will see B corresponds to A, D corresponds to B and C corresponds to C. C is the common angle. So we again will write it down. Angle BDC is equal to angle ABC is equal to 90 degree. Reason is same. What it is? Given and construction. So came to know given and construction. Common angle. C is a common angle. BCD and BCA. So angle BCD is equal to angle BCA. Reason is common angle. Very important. Therefore, triangle BDC similar to triangle ABC. Now side proportion. Let us take first. I told you that if you don't know, in the side you can write down the B corresponds to A. B corresponds to A. D corresponds to C. And D corresponds to, B. And C corresponds to C. C is a common angle. Now I want BC square. Means BC should be up and BC should be down. So if I take triangle BC in the smaller triangle is equal to in bigger triangle BC down. So if I take BC here, I will get it as in bigger triangle what? Bigger triangle what shall I get it? BC by AC. In BC I took over here, there what shall I get it as? DC. Cross multiplication. So by cross multiplication, what shall I get it as? BC square is equal to, what shall I get it as? BC square is equal to AC into DC. Very important. Just if you are not able to see this properly, once again I will write it down this properly. BC square is equal to AC into DC. This is equation number 1 and this is equation number 2. Now we got to know that BC square is equal to AC into DC. That is the second equation. First equation and second equation. We have to add these two equations. As I have no place over here, I am going to rub the statement and I will continue my proof on this side. So pay attention on the other side of the board. Just see. So what I am going to do, I am going to add equation 1 and equation 2. So adding equation 1 and 2. So what you will get if equation AB square plus BC square. So you add the left hand side first. So AB square plus BC square is equal to, what is AB square given as? AD into AC. So I will take it as AD into AC plus, what is second over here given? AC into DC. Now can you see over here? AC is there, AC is there. So on left hand side I can take out AC common. Right hand side will remain as it is. There is no change on right hand side. So what I will get? AB square plus BC square is equal to AC I will take out common. In the bracket, what remains if AC goes? AD. What sign plus? AC goes, what it remains? DC. Now see in the diagram, AD and DC, both if I add, I will get the side what? AC. So sum of AD and DC is AC. So I can write it down what? AB square plus BC square is equal to AC into AC. The reason I am writing down, because AC is equal to BD plus DC. From the figure you can see that AC is equal to, AD plus DC. So once again I am telling you, see, first equation we got BC square is equal to AC into AD square is equal to AD into DC. BC square is equal to AC into DC. Second equation we got. Now what we are going to do? We are going to add those two equations. Adding means what you have to do? Left hand side should be added to left hand side. Means AB square and BC square should be added. So it became AB square plus BC square. Then right hand side should be added to right hand side. What is right hand side over here? AD into AC. So AD into AC. Then what sign should come? Plus. Then what is another? AC into DC. So you wrote AC into DC. AC is over here also. AC is over here also. So you are taking AC common. By taking AC common, you will get AD plus DC. In the figure you observe, AC is made up of two line segments, AD and DC. If I add these two line segments, I get it as AC. So I have written AC is equal to AD plus DC. AC into AC is what? AC square. So AB square plus BC square is equal to AC square. Hence you have proved your theorem. What does the theorem says? Hypotenuse square is equal to sum of the square of the remaining two sides. So AB square plus BC square is equal to AC square. You have proved the theorem once again. I will explain you full. Statement, you already know the statement, but I will repeat the statement. What is the statement? Says that in any right angle triangle, prove that the square of the hypotenuse, which is the hypotenuse, the side which is opposite to right angle, that is AC square. So the square of the hypotenuse is equal to the sum of the square of the remaining two sides. That was a statement of the theorem. For that, what we did, we drew a triangle ABC where we took angle B as 90 degree. So what did we write the given? Triangle ABC is a right angle triangle. Angle B is 90 degree, we showed. Then to prove, square of the hypotenuse, that is AC square, is equal to sum of the square of the remaining two sides. Which are the two sides? AB and BC. Its square is AB square and BC square. So it is equal to AB square plus BC square. We cannot prove the theorem like that. We need to draw construction. What is the construction you are going to draw? Draw BD perpendicular to AC. So you are drawing BD perpendicular to AC. Perpendicular means what angle it will make? 90 degree. So draw BD perpendicular to AC. By drawing BD perpendicular to AC, we got two smaller triangles and one bigger triangle. So we are going to compare one part of the smaller triangle with the bigger triangle and another part of the smaller triangle with the bigger triangle. So we are going to compare ADB with ABC. So in triangle ADB and triangle ABC, and we are going to make it is similar. So to make similar, we require the criteria. So what criteria it is? Angle similarity criteria. So what we are going to do in triangle ADB and triangle ABC, angle ADB is equal to angle ABC is equal to 90 degree. Why? Because in B is given as 90 degree in the given, and in construction you have drawn BD perpendicular to AC, so angle D also became 90. So the reason is given and construction. Now look here, BAD or BAC is the same angle, that is which angle it is? Common angle. So angle BAD is equal to angle BAC, it is a common angle. So what happened? The two triangles became similar, that is triangle ADB similar to triangle ABC. So if the triangles become similar, we know in similarity triangle, what if we can take the side proportion. Now I want AB square. If I want AB square means in the smaller triangle, if I write AB in the numerator, in the bigger triangle AB should come in the denominator, because when I cross multiply I should get AB square. So I wrote AB and AB over here. So which side now I have to take? AB if I take, because AB if I take, A is corresponding to A and B is corresponding to C. So here in bigger side what will come? AC. So I wrote AC at the down. Here in smaller triangle I took, in the bigger triangle I took AB. So AB I have taken means A corresponds to A, B corresponds to D. So a smaller triangle in the numerator I wrote it AD. If I cross multiply, I got AB square is equal to AD into AC. Let this be as equation number 1. Similarly, I took BDC and ABC. In the same way, I proved angle BDC is equal to angle ABC is equal to 90 degree. Same reason given and construction. Next what I did, C is common angle, angle BCD is equal to angle BCA because it is common angle. So triangle BDC is similar to triangle ABC. So B corresponds to A, D corresponds to B, C corresponds to C. I want BC square means BC, the smaller triangle BC is in the numerator, the bigger triangle BC should come in the denominator, then I can cross multiply. So I took BC, so in a bigger triangle it will come AC, BC, AC. So BC by AC is equal to DC by BC. Cross multiplying, BC square is equal to AC into DC, which is your equation number 2. Now we have to add these two equations. So adding 1 and 2. That means left hand side should be added with left hand side. AB square is left hand side and BC square is left hand side. So if I add, I got AB square plus BC square. And the right hand side should be added with right hand side. So what is there in right hand side? First right hand side, AD into AC. So AD into AC plus, What is the second? AC into DC. AC into DC. In this you can see AC is common. So I took AC common. If I take AC common, AD will be remaining. If I take AC common, DC will be remaining. So AD plus DC. In the figure you see AD plus DC. AD is a part of AC and DC is a part of AC. Means AD and DC both are the line segments of AC. If we add these two, we will get AC. So AC into AC. What is AC into AC? Is AC square. Hence your theorem is proved that AB square plus BC square is equal to AC square. This theorem is useful for solving the problems. How? That is, if AB and BC is given, you can find out what is the hypotenuse. If hypotenuse and one side is given, you can find out the other side. Add the two square of the sides, you will get the hypotenuse. From the square of the hypotenuse, subtract any one side square, you will get the other side. We saw that Pythagoras theorem and I explained regarding the Pythagoras theorem. Now I want to show you that if in a right angle triangle, the 90-degree angles, the name of the 90-degree angles, whatever the letter you denote, that letter changes, how to find out the hypotenuse and how to find out the other two sides and how to represent the Pythagoras theorem in mathematical statement. For example, this is a right angle triangle. I am going to give the name as P, Q and R. And this is 90 degree. So, how will you represent the statement of the Pythagoras theorem for this? So, what does the statement says? The square of the hypotenuse. So, which is the hypotenuse? QR. So, how it will become? QR square is equal to sum of the square of the remaining two sides. Which are the other two sides? PQ and PR. So I will get it as what? PR square plus PQ square. Okay. Now I am going to change. This I am going to make it as Q and this I am going to make it as P. So I have changed the right angle now. So now what shall be the Pythagoras theorem based on this when Q is 90 degree? This is when angle P is equal to 90 degree. You got this. Now angle Q is equal to 90 degree. What shall you get? The Pythagoras theorem. So again you see the hypotenuse, which is the hypotenuse PR. So you will get it as PR square is equal to the two sides. Which are the two sides? PQ and QR. It's square. So PQ square plus QR square. Now I am going to change this and R I am going to take it as 90 degree. So angle R becomes 90 degree. That time what will be your Pythagoras theorem? So which will become the hypotenuse? PQ. So PQ square is equal to PR square plus QR square. So children, you have to keep in mind that the hypotenuse is very important. Whatever the angle may be, whether it is P is 90 degree or R is 90 degree or Q is 90 degree, you should be able to find out first the hypotenuse, then the other remaining side you will get. So you have to write it down. See, if P is 90 degree, QR square is equal to PR square plus PQ square. If Q is 90 degree, PR square is equal to PQ square plus QR square. If R is 90 degree, PQ square is equal to PR square plus QR square. See, one more I will give you the clue. See, if P is 90 degree means the two sides P, R and PQ. See, P, because this is the angle P is 90 degree. So that these two sides you have to take, that is QR will become the hypotenuse. So PR plus PQ, because the remaining two sides will make the 90 degree. So here PR and PQ should come. See here PQ, QQ came because Q is 90 degree. And here RR came because R is 90 degree. So came to know how to do this. Okay. Now one more thing I want to teach you. Very easy it is. If two sides are given, you have to find out the square of the, you have to find out what is the hypotenuse. So what it will be, hypotenuse square, so it is very easy formula. Hypotenuse square is equal to first side square plus second side square. Okay. Now, if hypotenuse is given and one side is given, you have to find out what is the second square. So, what is the formula for that? Then, second side square is equal to hypotenuse square minus first side square, and second side will be equal to square root of hypotenuse square minus first side square. So remember this, when any one of the side is given and hypotenuse is given, how to find out? Orally you can take the hypotenuse square of the hypotenuse minus the square of the given side, then take the square root, you will get the second side. If both the side is given, take the square of both the side, add and find the square root, you will get the hypotenuse. So came to know how to do this. So this is what the sums will be based. So next video I will teach you first the converse of the Pythagoras theorem, and I will show you the sums based on Pythagoras theorem. Till then, be safe, be at home. Bye children.